We're live and we're recording. Okay, so 2026 Jan, moments question number 14. For the mark scheme, you can go to the end of the video. And I want you to pause the video and try out the question yourself. Read the question very carefully and try it out. Now, I want you to just read the question. I'm gonna answer part A straight up. So we have been given this diagram. We have a horizontal bar, we have a supporting bar, we have a container, we have chain, and then we have a hook. And that's all connected to this wall we can see on the diagram. And part A says to us, the container is in equilibrium. That's an important part of the question. And then it says state why the center of gravity of the container is vertically below the chain. Now let's say you don't understand the question. I recommend drawing it out first. So it's going to be somewhere right over here, vertically below the chain. So this is going to be where the weight is going to be acting. Okay. And what I want you to look at is the key word here is going to be equilibrium. Equilibrium means the sum of moments or the sum of moment or the resultant moment is equal to 0. And that's the key point here. Now, what I want you to do is just consider the container and how many forces are acting on it. There's going to be a tension force right over here. There's going to be a tension force right over here. I'm going to take this point as the pivot. We can see that the line of action, we have studied this before many times. I've seen this in every past paper. The line of action, if it passes through the pivot, the moment due to that force becomes 0. Okay, I'll write the thing here again. So here you can see, remember line of action concept. You're going to select a pivot, see if the line of action of force passes through the pivot. If it does, then there is no moment due to the force. If it doesn't, there is a moment due to the force. So we can see that there is no moment due to the two tension forces. And the reason the weight is also directly below the chain is because you can see we draw the line of action of the weight, it passes through the pivot as well. Hence, the resultant moment is 0. Now let's say our weight was somewhere here. If it was here, the weight's line of action wouldn't pass through the pivot, so there would be a resultant moment, and hence the container wouldn't be at equilibrium. So the answer to this is, as I'm going to write it down. So the answer will be as the resultant moment is equal to 0. The reason there is not much explanation in this question is because it's a state question. State means just write the thing down and move on. Okay, so that's going to be this part. Let's move on to the next part. It says a screw in the wall exerts a force F on the horizontal bar as shown. The weight of the container is 34 newtons. The mass of the bracket is negligible. Determine force F, and they've even given you help there that you should take moments about P. So first thing I'm going to do is I'm going to label the forces that are acting on the entire system that we have over here. So we have the weight acting right over there. And then what we need to do is we need to see and find the perpendicular distance. So the perpendicular distance from the pivot to the weight, we know that is 0.28 meters. The next thing, we need the perpendicular distance from the force F, which is the force that the screw exerts on the horizontal bar. We need that force. And we need that distance, the perpendicular distance, so we can move further on. So we need this distance right over here. This distance D. So what we can do is we can just use the SOHCAHTOA and we can easily find the distance D. So we can see here that our tan 55 is equal to 0.16 divided by the adjacent, or we can just put the distance that we are trying to find out. So let me plug that into my calculator and then we get the answer. So I'm getting a value for a distance of 0.112 meters. So that's going to be the distance D. Okay, so now we're going to see that the weight has a clockwise moment and that the force F has an anti-clockwise moment. So we can say that the anti-clockwise moment is equal to clockwise moment. We can say that the weight, which is 34 times 0.28 is equals to the force F times 0.112. So we plug that in the calculator, and we should get the answer as 34 times 0.28 divided by 112. Our force F answer will be 85 newtons. So you plug that in there, and then, yeah. Okay, that's the question. And yeah, now I'll show you the mark scheme, and then we'll end the video.